How extreme is extreme? That is the focus of this presentation, and more specifically, how extreme can a flash flood be in this steep catchment in the western part of Norway. This is based on a case from Utvik in 27, and here is the background story. My name is Oddbjørn Bruland. I'm a professor in hydraulic engineering at NTNU. This is my home village, and I was present during the entire flood and tried to document what was going on at the same time as I tried to protect my property as good as I could. The last one didn't succeed that well, but it could have been worse. It could even have been worse. My boathouse is probably from the mid 1700, maybe 1800, so that had been standing for a long while. So this is not something that happens frequently. It was quite extreme, and based on my documentation I have tried to do some analysis of how extreme this actually was. It's very difficult to say what was the discharge when it looks like this. It's impossible to measure, and it's impossible to estimate. Here is a bridge that is about between 20 and 30 square meters in the opening, and with that high water velocities that was at the time, it's quite steep here. It's probably between maybe 150 to 300 cubic meter per second passing through here. And you see the capacity is not high enough. But how much rain was necessary to create this event? That is also an interesting question. Nobody in this village have ever experienced anything like this before, and up in the mountains it was much more extreme than down in the village. So can these questions be answered? Based on the observations, based on measurements done in the Afterwards, we have tried to say something about what happened. Here is a dam crest, and under normal conditions it's possible to estimate the discharge of such a dam crest. But could that be done when the flow is that turbulent and then that messy as it is during this event? We have the formula based on the water depth behind the crest. We can say something about the discharge. And the water depth was estimated based on the damages seen on the house in the background. 2.36 is probably a conservative estimate. You also need some idea about the velocities that also contribute to the discharge, the water velocities behind the dam crest. This was estimated, or this was tested in a flow of 10 cubic meter per second with a homemade debris floating device, and at this discharge the velocities was around 1.5 to 2 meter per second. It was probably significantly higher during the flood. And how was the flow distribution over this crest? It was flooded also to the left of the crest and also to the right, but the main portion went over the crest. These aerial photos could be used to say that it was probably something like this, but this is where the erosion was, and it was probably higher also than this, wider than this. But how was the flow distribution? Just by common sense we could say that it could be something like this, with lower velocities to the left and the highest over the dam crest in the center. This is a model of the dam crest with all the measures and all the measures at the side of the crest. Based on this, the depth and the size of the dam crest and the estimated distribution of the flow, and a flow velocity upstream between 4 and 6 meters per second, and a dam crest coefficient ranging from 1.7 to 2, we could say that the water discharge, or the discharge, was between 180 and 300 cubic meter per second. Most likely a lower dam crest coefficient is reasonable, and then between 180 and 270 cubic meter per second. This was tested also by the velocity and area calculations, and it seems like an estimate of 200 cubic is reasonable with the water velocity about 4.5 upstream the crest. It was also tested with different distributions of the flow, and also this shows discharge between 180 to 300 cubic meter per second. Furthermore, it was set up a hydraulic model for the upstream the dam crest, and doing simulations to test what kind of discharges was needed to get a water depth of 2.36 at this point over the crest. It was tested with discharges from 160 to 250 cubic meter per second and with varying roughnesses upstream. Most reasonable or most probable discharge was then estimated to be around 200 cubic meter per second. And how much is 200 cubic meter per second from a catchment of 25 square kilometers? It's quite a steep catchment, as you see at the hypsographic curve. Not all of the area was contributing equally much. The catchment was investigated, and all the rivers, or many rivers in the catchment, was investigated to see features from erosion and high discharges. And it was found here that here was a lot of erosion. Here was the flow had been high here, and you could also see at the slopes beside the river that here have been high discharges. Further up it was still erosion, but here it was significant, but it was still less than further down. And up here you could see very clearly that it was not the same clear signs of heavy runoff, nor in the river and nor on the slopes beside. So somewhere in between here, it was the discharge was reduced, or the influence was reduced. The catchment upstream the dam crest is 22.5 square kilometers. This river had significant signs of really high flow. It took another path also further down, and they were obvious that the discharge here was very extreme. The same with this river. That took also another path and went through or between the houses on a farm there, as you see, and made significant damages. This river also had quite high flow and made also damages. The other rivers didn't have the same kind of damages along themselves, indicating that the discharge further down was not that high. This river have in common this area, and it is assumed that this area was the area that contributed most to the flow, where this precipitation was the highest. This is about 13 square kilometers in this catchment. So how much is 200 cubic meter per second from 13 square kilometers? That means 15,385 liters per second per square kilometer in specific discharge. Is that high? If the entire catchment was contributing, it would be 9,000. So somewhere in between 9,000 and 15,000 liters per second per square kilometer is likely. This is about 2 to 3 times higher than the highest previously observed specific discharge in Norway. This is from a place in eastern Norway and was about 5,300 liters per second per square kilometer. It is more comparable to extremes observed in South Europe in the Mediterranean area. This is summarized by Gaume et al. 2009. And even compared to these floods, it's quite high. So this means that even in the northern latitudes, we can have extreme situations comparable to those we see in southern Europe. Compared to the 1,000 years floods calculated for Norwegian rivers, it is also very high. So, was this a 1,000-year flood? That's an interesting question. But for these calculations are made for larger catchment, and since this is quite a small catchment, it is supposed that the specific discharges here are higher. But it is probably quite extreme. So how much rain was this? During this event it was observed a waterfall up in the mountains in the background to the right that had never been observed before. So what happened up there? And how much water is needed to create a waterfall? As waterfalls is an important landscape element, this has of course been investigated. How much water is needed to create a waterfall that have a visual effect? This also made a database of waterfalls showing the discharge per meter waterfall and also pictures illustrating how they look like. Based on this, we can say something about also this waterfall. The area behind this is 0.14 square kilometers and the width of the waterfall was between 50 and 70 meters. The catchment looked like this. It's quite shallow soils and the response here is quite fast. And the lower picture shows the region where the waterfall was falling out over the mountain. This is the river, or it's more a creek. Normally it's almost no discharge or water in this river, but during the flood there was quite a high discharge also here. This indicates the water level that was probable during the flood based on observations of things or along the river. So how much precipitation is needed to create such a waterfall? Based on the assumptions from the reports and the database of waterfalls, it's likely that it was between 90 and some over 100 millimeters per hour that is needed to create such a waterfall, visible from 5 kilometers away. It indicates, it isn't a proof, but it indicates that the precipitation must have been very high up in the mountain here. Another small catchment draining down to a pond created early in the 1900s for fishing, sport fishing. There is a dam crest. It was done observations of the water level also above this dam crest to test, to make an assumption or an estimate of the discharge from this area. It shows that the water level was between 10 and 60 centimeters. It's quite variable, but based using the same formula, we could say that we could estimate the discharge to be between 12 and 15 cubic meters per second over this dam crest. That is a specific discharge between 5,000 and 6,000 liters per second per square kilometer. Upstream this lake, it was also clear that the river have divided and a significant part of the river have gone to the eastern side. So the 5,000 to 6,000 is very conservative, but still it's very high. But probably it was significantly higher here. So how much rain was needed? There are some observations of precipitation gauges around in the area, and these were used in a distributed model to calculate how much discharge they would have given. The radar images indicate that the most intense part of the precipitation was over the mountain and in that region. So using this information and observed precipitation and also manipulating the precipitation in the area where the precipitation was highest, we tried to reconstruct the flood. It started around between 4 and 5 in the morning to increase and went up to 180-90 cubic meter per second in around between 7 and 8 in the morning, and then decreasing later out on the day. Even it looks really bad later on, the discharge was still lower than it was at the peak. So even here it was less than at the maximum. So how much rain was this? 60 millimeter per hour at the maximum in average over the catchment, but 125 millimeters in the 3 hours in average over 20 square kilometer, or 150 millimeter in 3 hours in the most intense area of 2 square kilometer. Compared to the duration curves in this region, this is 3 times as high as those estimates for the 200-year flood, 200-year rain. So that indicates that yes, it is quite an extreme event. But was it the deluge? Probably not, but was it a 1,000-year flood? Was it a 500-year flood? Or was it a flood that should be used for dimensioning of infrastructure in this region? This is an interesting question that is addressed in this publication, which summarizes the calculations and the event itself, and is available at Hydrology Research for those that are interested. Thank you. That was all.